Alright, we're going to look now at the practice page for Thursday, 8/26, solving for an indicated variable, x and y only. We will be doing other examples of this. This is kind of like a day one of this, but I think we're going to wait till everybody gets back for that, hopefully. What you'll find is that these are pretty repetitive, so once you get the pattern down, they're pretty straightforward. Hopefully you saw that from watching Ms. Roundtree's video. But here we go. So starting with number one, important. The directions tell us specifically that we are going to be solving for y. Okay. In other words, I need to try to get y on a side by itself. On number one, what we always want to do is we have two terms. We have 3x and we have y. We always want to start by getting the x term moved to the other side. Okay. So to do that, we use inverse operations. Since we're adding these two terms together, and that's a positive, we're going to subtract 3x once from each side of the equation. Okay? And of course, what happens, 3x minus 3x cancels out. Zoom this in just a little bit. There we go. And then that leaves me with y equals, and over here, there's a couple of ways we can write this. We could write 1 minus 3x, okay? But if you remember from middle school, and this is very similar to something called slope-intercept, which will come back later, y equals mx plus b. In general, you want to put the x term before the constant being the number without a variable. So if we were to do that here, this is very important. This is or. You could write y equals negative 3x plus 1. Again, this is a positive 1, right? So if I flip the two terms, I have to take the sign that goes in front of each one with it. So the plus stays with the 1, the minus becomes a negative out in front of the 3. Okay. Technically, either one of these are correct. We've solved for y. We're done with this problem. But if you're looking for the more standard way to write it, it would be the second one down here on the bottom. So that's the way that I'm going to write most of my answers. Okay? Let's move on to number two. Number two has more going on. The reason is it has a coefficient in front of the y as well. But your first step does not change. I still need to move 5x. It's a positive 5x, so I'm going to subtract 5x on both sides. Okay? 5x minus 5x cancels out. Bring the 2y down. And on this side, again, these are not like terms. One of them has an x, the other one doesn't. So I can't combine them, so I just bring them both down. Again, I choose to put the x term first. You don't technically have to, okay? But I'm going to be doing it the same way over and over again, so it's a good habit to get in it's a good thing to get in the habit of. Now the problem is, I'm not done here. I have not solved for y yet. I don't have that indicated variable by itself. So the only thing connected left to that y is the 2, and the 2 is connected through multiplication. So I have to use the inverse operation for multiplication to get rid of that 2. Well, the inverse of multiplication is division. I'm dividing the left side by 2, which means I have to divide the right side by 2. Not just the 5x or the 4, but both. Both. Okay? And what's going to happen is 2 divided by 2 cancels out. And I'm left with y equals negative 5x minus 4 divided by 2. The whole thing divided by 2. And if this were multiple choice and that was an answer choice, you 100% can leave it like that. Okay? However, oftentimes they will take these problems a step further and simplify this by dividing the 2 into each of the two terms. In other words, they would rewrite it like this. Y equals negative 5x over 2 minus 4 over 2. And then we can clean that up. Alright, so that would be negative 5 over 2 doesn't really simplify, so negative 5 over 2x. And then minus 4 divided by 2, which is 2. This is the most simplified answer, but all three of these are technically correct. And I'm pretty sure we would get, all your teachers would give you credit for any of these on this particular assignment, because the directions simply say solve for y. Okay. So once you get y on a side by itself, that's all you technically have to do. Alright, for the next one, again, same thing. If you want to put the 1 there to remind you that's a 1x, we need to move that. Now this is subtraction, but be careful. The thing we want to move, the term that we're trying to move, is the 1x, and that is positive. So I don't need to add 1x, because 1 plus 1 would make 2. I want it to cancel out. So I actually need to subtract 1x. Okay, I'm going to do that once on each side. 1x minus 1x cancels. But now when I bring down, this is super important, when I bring down this 3y, I have to remember that it had a negative or a minus in front of it. So that comes down as negative 3y equals negative 1x plus 9. Okay? The next step is going to be to somehow get rid of this negative 3. Now some people see that there and they think about it as a minus and they want a plus. No, no, no. How is that negative 3 connected to y? It's connected through multiplication. So to undo multiplication, we're going to divide by negative 3. And if I do it to one side, I must do it to the other. Okay, so negative 3 divided by negative 3 cancels out, leaving me with y equals, and then over here, you can write negative 1x plus 9 over negative 3, but we can simplify that by dividing the 3 into both terms. So that would look like this. And then plus 9 over negative 3. Then we need to clean that up. Negative divided by negative is going to be a positive. So that's going to be 1/3 x. And then here I have 9 divided by negative 3, which is going to be negative 3, but I'm adding a negative. Okay, so I'll write that plus negative 3. And you can put parentheses around it if you want to. Which then, adding a negative is the same thing as subtracting. Okay, so final answer would be 1/3 x minus 3. Okay. Okay, that's what y equals. So equals y. Alright. Take a look at this one. Number 4 looks a little different. I'm still solving for y. The directions haven't changed. But this time x is already on a side by itself, so I need to move different things, other stuff. Okay? So what I need to move here is this 6. And it says it's connected by addition, but again, that's a negative 6, so I wouldn't want to subtract 6 because negative minus 6 would be a negative 12. Okay, so I want to actually add 6 so that negative 6 plus 6 cancels out. That's what I'm trying to do, is get that to cancel out through using the inverse operation. So, when I rewrite this, I get x plus 6. Again, not like terms here. You can't just call that 6x. It's addition, not multiplication. Equals 2y. Alright? Y needs to be on a side by itself, so now the 2 needs to go away. How is that 2 connected to y? Through multiplication. So I have to divide both sides by 2. Conveniently cancels out here, which is the whole idea. And again, x plus 6 over 2. That is fine for your final answer, or you could simplify it, x over 2 plus 6 over 2 equals y, which you could clean that up to 1/2 x plus 3 equals y. Okay, moving on to number 5. 7x plus y equals 2. This one's pretty easy because I don't have a coefficient in front of the y. All I have to do is move that 7x. So I subtract 7x on both sides. All that's left over here is y. And I have negative 7x plus 2. Again, I choose to put the x term first. You technically could put 2 minus 7x and that would be fine as well. But I like to go ahead and put my x term first. That idea of standard form that we talked about earlier in the year. Alright. Number 6, last one. This one is a little bit tricky. We need to understand what this means right here. That's an understood negative 1. And that's negative 1 times y. So what I need to do to get y by itself here is divide both sides by negative 1. And that leaves me with y equals x minus 1 over negative 1. Again, I could leave it like that. It's not technically wrong, but it's not fully cleaned up or fully simplified. So I could break that up and do 1x divided by negative 1 minus 1 divided by negative 1. And again, that right there comes down as the minus here. It doesn't go to both places. Now I just clean up both of those fractions. 1 divided by negative 1 is going to be negative 1. So y equals negative 1x. Okay. And then 1 divided by negative 1 is negative 1, so minus negative 1. Still haven't fully cleaned this up. I don't have to write the 1. I could choose to write just negative x. And here, minus a negative, subtracting a negative, is the same thing as adding a positive, which you should remember from middle school, hopefully. So that becomes a plus 1. And this would be fully simplified. And again, you can kind of see the reason why you might want to take those steps. This looks much cleaner than this. And eventually you're going to get to equations like this where we have to graph them. And when you graph this, this is much easier to graph than this up here. Okay? Alright, flipping over to the next one. And the first thing I want to point out is that there is a direction change at the top here. There it is. In these problems, we are going to be solving for x, not y. All that does is it changes the order that we move things around in. If I want to get x on a side by itself, then I don't need to move x. I need to move the other term, the term that contains the y. So for this first problem, number 7, we would add 2y to both sides. Okay? And that's going to give me 5x equals 2y plus 8. Both are positive. Okay? Now the next step is going to be to divide both of those sides by 5. 5 divided by 5 cancels. And then on the other side, you can choose to do it in multiple steps. And I'll keep doing that so I can see it. Or you could choose to go ahead and split it up, right here from the get-go. But I'm going to write 2y plus 8, all divided by 5, which we then can clean up and simplify to 2y over 5 plus 8 over 5. Now, you'll see on this one it doesn't clean up to nice, neat whole numbers. We're going to leave them both as fractions, no big deal. So 2/5 y plus 8/5. Okay? And that's fully simplified. Alright, keep going here. So again, solving for x. So I need to add y to both sides. I do that because minus y plus y cancels out and goes to 0. Leaving me with x equals, and over here I'm going to have y minus 2. I didn't have a coefficient in front of the 2, so I don't have to do that division step. What you should see is all of these problems follow the same general process. You are either adding, subtracting one term or the other first, and then you're dividing by the coefficient that's left, if there is one. Okay. Alright, moving on to number 9. Again, solving for x, so we're going to add 3y to both sides. And just like on the last one, we get x equals 3y plus 9, and I don't have to do any division because, like I said, there's no coefficient in front of that variable that I'm trying to solve for. So that is 100% complete. Okay. Number 10. I need to get x by itself, so the first thing that's got to go is this minus 5. Okay, so to get rid of that, since it's a separate term, I'm going to add 5. Minus 5 plus 5 cancels out. I get y plus 5 equals 2x. Again, don't forget what you're solving for. We're solving for x, so the 2 needs to go. It's connected by multiplication, so in order to get rid of that, I need to divide both sides by 2. Again, you're dividing the entire side by 2, not just part of it. Okay? So, y plus 5 equals x. Oops, sorry. Y plus 5 divided by 2 equals x. Now, again, we can clean this up. We can do y over 2 plus 5 over 2. You can divide that 2 into both parts, both terms. And then that's an understood 1. We could rewrite this as 1/2 y plus 5 over 2 equals x. Alright. Fully simplified here. And again, really the only difference between any of these three is if it's multiple choice, are you going to see this answer or would you see this answer? And the correct answer is you'll see one or the other. You're not going to see both. So you would choose whichever one is there. Either you would choose this if it's there. If it's not, then you need to divide that 2 into both parts to get this answer and then see if that answer is a choice. Okay? Which one of them should be if you've done the work correctly. But as far as if it's an open-ended question like your homework, I don't want to speak for your other 3 teachers, but I would take any of these 3 because the directions specifically say solve for the indicated variable. It doesn't say solve and then fully simplify. It's a good idea to simplify, but technically once you've solved, you've done what the directions asked you to do. Okay? Alright, number 11. Again, I'm solving for x, so the other term needs to go first. It's connected by addition. Oops. So I need to subtract 5y on both sides. I almost messed that up. 5y minus 5y cancels. 2x equals negative 5y plus 5. Last step in solving for x is going to be to divide by 2. And we get x equals negative 5y plus 5 over 2. And of course, I'm going to clean it up. Alright. Just like I have on every other problem. Negative 5y over 2 plus 5 over 2. And it cleans up like that. Okay. Alright, number 12, final question. I'm solving for x. First thing needs to go is whatever's on the side with x. Now in this case, something unique is going to happen here. And I'm actually going to show this problem another way. Another idea. I'm not sure anybody would think to do this, but you might. But you might, and if you did, I want to show you that it works. So I'm going to draw a little line here. And I'm going to work it the way we've been working the rest of the problems. And then I'm going to show you a secondary way you can kind of think about this one. If you see it, if you visualize it, you can do it this way. Alright, so subtract 15 on both sides, because that's a positive, a plus 15. I need to undo a positive 15 with a negative 15, or a minus 15. So we're subtracting 15 on both sides. So this is going to be 5y minus 15 equals negative x. Now, again, understood that's a negative 1x. So to get that x by itself, I need to get rid of that negative. And it's multiplied as a negative 1. So I divide by negative 1. Which of course cancels. I get x equals 5y minus 15 over negative 1. I can then clean that up. 5y divided by negative 1 minus 15 divided by negative 1. Clean up the individual pieces. 5 divided by negative 1 is negative 5, so negative 5y minus 15 divided by negative 1 is negative 15. And I have that scenario where I have those double negatives. So subtracting a negative is the same thing as adding. So negative 5y plus 15. And that would be your fully simplified answer. Alright, now, I'm going to switch over here and tell you how I think about this problem. normally we say we don't move the x, but in this scenario that x is negative. Well, what if I moved the x to the other side? What would happen? So to do that, I would add x, right? So plus x on both sides. And that cancels, leaving me with 5y plus x equals 15. Well, now, if I then move the 5y to the other side, I'll have x by itself, and it'll be positive. So subtract 5y, and you get x equals negative 5y plus 15. Which means you get the same answer. So my whole point in saying this is, and especially in that last one is, there are different steps that you can take on these problems. There's a way that I kind of did for every single problem, but there are other ways you can kind of work around some of that, especially when you're trying to avoid negatives. So if you want some more help with that, maybe reach out to one of your teachers, or ask us when you get back in class. But there's your 12 examples. Good luck with the homework, and again, reach out to us if you have any questions. The best way to get in touch with us is through our emails. Good luck.